10.6 day 2 is some more polar stuff. Number 1, find the area in between the inner and outer loops of r equals 1 minus 2 sine theta. So basically what we want is we want this area. So we want the area in between the inner and outer loops in this polar equation. So let's walk ourselves through some of this. What does 1/2 times the integral from 0 to 2 pi of 1 minus 2 sine theta squared d theta calculate? Well, if we go from 0 to 2 pi, 0 will start here, and then we'll move ourselves to pi over 6, get ourselves to pi over 2, get ourselves to 5 pi over 6, get ourselves to pi, get ourselves to 3 pi over 2, and get ourselves to 2 pi. Basically, what's going to happen is if we sweep area, we're finding this area, plus this area, plus this area, plus this area, and then we're getting all of this area. So notice what's happening if I go from 0 to 2 pi is that the part that's on the inside is being double counted. It's counted as area that's green and area that's black. So that's bad. Like, we don't really want that. Oh, sorry about that. So that's not too good. We don't want the area inside the red and the blue. There's some double counting. So if we take a look at this, we end up with the area inside the blue and the area inside the red for those two calculations. And that's basically what we want. We want to take the area that's inside the red, subtract the area that's inside the blue, and then we end up with a victory here. That gives us the area that we actually want up above. So let's calculate that. So if we find the area that's inside the red and subtract the area that's inside the blue, we end up with exactly what we wanted. Next problem. Find the area inside of r equals 1 and outside r equals 1 minus cosine theta. Now, C is clearly not correct, but A and B are both candidates. If we were looking at A, that would be the area inside 1 minus cosine theta and outside 1 minus sine theta, and outside r equals 1. So basically what that would be is that would be this area that I'm kind of shading in with my mouse right now. If I did the proper integrals subtracted from each other. But B is actually going to be the area that we're looking for. B is the bounds that we're looking for because we want this shaded area that I'm moving with my mouse right now. So I want the area inside r equals 1. So I'm going to find the integral from negative pi over 2 to pi over 2 of r equals 1. And then I'm going to subtract the small areas of the cardioid that are from negative pi over 2 to pi over 2. So I'm going to set up my integral as such. Notice that it basically gave me this formula down here that I neglected to talk about, but you can read that. Now, one thing you might want to notice is that this is actually just a half circle with radius 1. So I can simplify my calculations by just making that pi over 2 right away. So now I go from 1/2 the integral from negative pi over 2 to pi over 2. I distributed this out. One reminder that cosine squared is equal to 1 plus cosine 2 theta all over 2. So now I can replace this with 1/2 plus cosine 2 theta over 2. 1 plus 1/2 equals 3/2. That's where that comes from. And now I integrate. So it becomes 3/2 theta minus 2 sine theta plus sine squared theta, or sine of 2 theta over 4. I'm going to evaluate that. And I end up with, I'm still not very good at these things that hide answers, but I end up with pi over 2 minus, remember that all of this has to end up being multiplied by 1/2. That's how it becomes 3 pi over 4, even though I have 3 pi over 4 plus 3 pi over 4. I end up multiplying it by 1/2, and I just get 3 pi over 4. So it becomes 2 minus pi over 4, which is about 1.215. If this were a calculator problem, obviously you would just type this in to your calculator and get the answer. Make sure that you're very careful with your parentheses, however. If it's not a calculator problem, then you have to do all this work and remember a trig identity. Hey, see these 3 things? You're going to have to know them. I'm not going to spend a whole lot of time deriving them because it's really not worth deriving them at this point in time. The textbook derives them. If you have more questions, you can ask either Mrs. Casey or I in class, but these are the length of a polar curve, arc length of a smooth curve, which you already should know, and arc length of a smooth parametrized curve, which again, we already learned in this chapter. So this was learned a long time ago, this was learned a few days ago, and this is now the new one that you have to know. Number 2, find the length of r equals 1 minus cosine theta. So we're going to find basically the length of this. You have to know how far it is from alpha to beta. So that is the period of a cardioid, which is 2 pi. So I'm going to use the formula. So I have r squared plus dr d theta squared. So then I distribute. I realize that cosine squared plus sine squared equals 1. And then I can factor out a 2. And so the square root of 2 times the square root of 1 minus cosine theta. We now need another trig identity in order to continue to solve this by hand. If this were a calculator problem, you would clearly just type in the original and get the answer. But we're assuming this is a problem by hand. So we have to note that sine of theta over 2, a half angle identity, is equal to the square root of 1 minus cosine theta over 2. We can get that if we know the double angle identity and then just take a square root. So if I multiply both sides by the square root of 2, I get root 2 times sine of theta over 2 equals root 1 minus cosine theta. So that's that. Sorry. Then I end up with 2 times negative 2 cosine of theta over 2 after I integrate. Root 2 times root 2 is 2. So that's where that came from. And that's evaluated from 0 to 2 pi. I'm just going to multiply that negative 2 to the outside to make calculations a little simpler. And then I end up with negative 1 minus 1. So negative 4 times negative 2 is 8. And yes, the answer is 8. I know that sounds a little sarcastic, but if we're taking a look at this picture, it's not immediately clear that with all of this curviness that the answer would be 8, but the answer is 8. Okay, finally, surface area. Here are surface area formulas. There are 2 of them. One, if you rotate or revolve the curve around the x-axis, then you have 2 pi r times sine of theta. And if you revolve it about the y-axis, you have 2 pi r times cosine of theta. Notice that x must be greater than 0 here, and y must be greater than 0 here. We're going to do this exactly once. We don't want it to trace the curve more than once. One other thing about this is if you're doing this on the calculator, what you're going to notice is that r1 equals square root of cosine of 2 theta, and then r2 equals r1 squared. That's because we have this this function where r squared equals something. So the calculator won't be able to handle anything where cosine of 2 theta ends up being negative. So when you graph this on the calculator, I actually did it and I showed you what my window was and what my theta, min, and max were. But notice that there are going to be some things that the calculator can't handle. And that's because when you type this in, you're dealing with a square root. It doesn't actually have r squared on one side. So you have to kind of live with the best thing you can. So notice that negative pi over 4 to pi over 4 give us the bounds of one tracing of the right-hand loop. So now what we want to do is we want to revolve this around the y-axis. So we're going to get a surface area that's associated with this thing getting revolved around the y-axis. So that means it's going to get revolved this way. And so we'll get the surface area that's associated with that. So first thing I want to do is I want to do dr d theta. That's because I need it for the formula. So dr d theta is, if I take r, I could just take r from over here and take the derivative of that with respect to theta, or I could do the derivative of r squared. What's the word I'm looking for? I can do the derivative of r squared implicitly. So I could have done 2r dr d theta equals -2 sine of 2 theta. And then I could have divided by 2r, and then I could have replaced r with this, and I could still end up with the exact same answer. So you could have calculated it from here, or you could have calculated it from r squared. Either one is fine. So if we're looking at continuing this problem, I'm going to integrate, and this is kind of a nasty formula. So notice that I'm having 2 pi times r. R is root cosine of 2 theta, times cosine theta, times the square root of r squared, and r squared was already given, plus dr d theta squared. So I'm going to take this and square it, d theta. Now, a lot of this ends up canceling out, so it works out really well. So I just moved the 2 pi to the outside, rearranged these so then my mind can work with it easier. And then I got a common denominator inside the square root. Cosine squared plus sine squared equals 1. And notice that there's a root cosine 2 theta and now a root of 1 over cosine of 2 theta. Well, those multiply together to be 1. So now I just end up with the cosine theta. That's all that's left on the inside. So I do a little bit more calculating and simplifying and integrating, and I end up with 2 pi times root 2 over 2 minus negative root 2 over 2, which ends up being 2 root 2 pi. And I hope you've enjoyed calculus videos this year.